What's up everyone, welcome back. Patrick here, and in this video and the next couple of videos what we're going to deal with is adding and subtracting rational expressions. So we're going to jump into a couple of examples right away. Before actually doing these, I want to review some fundamentals of adding and subtracting fractions. So let's say that we have something like 2 over 3 plus 1 over 2. How would we add these two fractions over here? Well, we first have to get a common denominator between them. And what is the lowest common denominator between 3 and 2? It's going to be 6. So to get this 3 to become a 6, we have to multiply by 2. Means we have to multiply the top by that same expression, 2. And to get this 2 to become a 6, we have to multiply by 3, which means we have to multiply the top by 3. So we would end up with 4 over 6 plus 3 over 6, which ends up being 7 over 6. So now we can combine it into one fraction. So we're going to be using the same sort of methodology when we're dealing with these kinds of questions. Now, another example, let's say that we have, let's say 4 over 9 plus 1 over 3. What's the lowest common denominator between these? Well, notice it's 9. Right? 9 can go into itself one time, and 3 can go into 9 3 times. So really, we just have to multiply this by 3, and then this by 3. Now, you can multiply these two together, right? 9 times 3 would give you 27. So then you'd have to multiply this by 3, and this by 3, this by 9, and that by 9. But then 27 is not the lowest common denominator. It's a common denominator, but it's not the lowest common denominator. The lowest common denominator is 9. And when you do this, what this allows you to do is when you add these up, you end up getting 7 over 9. It allows you to get the simplified answer right away. You don't have to worry about simplifying further. If you multiplied these two, then you can add them. You get the same answer, but you have to do more steps. You're going to have to simplify at the end. So in my opinion, it's better to get the lowest common denominator from the get-go. And the reason why I wanted to bring that up is because a lot of times that's going to be happening here. So for example, notice with this x and x squared, the lowest common denominator between these would be x squared, because x squared goes into x squared once, and x goes into x squared x times. Right? You can multiply them, x times x squared, which would give us x to the 3. But then you're going to have to simplify more at the end. There's going to be more steps. So I'm going to go over a bunch of examples in this video and the next video where this process is going to become easier for you to see as long as you're following along. But yeah, just look out for that, where getting that lowest common denominator at the beginning is going to save you a lot more hassle at the end, especially when questions start getting more and more complex in the future videos. So let's apply that same methodology here. Now, those general steps that we covered when we were multiplying and dividing, those same steps apply here. So the first thing we want to do is we actually want to factor everything. Then we want to get the restrictions. And then we want to simplify. It's just that simplifying process is going to be a little bit different now because we're dealing with different operations, not multiplying and dividing. But these two steps are still going to be the same. You look at all the expressions, see if you could factor them, then get the restrictions, then you simplify. So over here, notice can't factor anything. And now we're going to get the restrictions. So 4 can never equal 0. Notice x. Let's write it over here. X cannot equal 0. That's basically the only restriction for this. Right? So I'm actually going to write that restriction over here. Right? That's the only restriction. And remember, when we were dividing, we had to work with the numerator of that expression that we were dividing. What's nice with subtracting and adding, we only have to work with the denominators. We don't have to worry about like a numerator. If there's an expression in the numerator that would make it equal to 0, that's not going to be a restriction. We're only going to be looking at the denominators. All right, so from here, what is the lowest common denominator between 4 and x? It's actually going to be 4x. right? We would multiply these two, so we multiply this by 4, multiply this by x, the top by x. So we would end up having 8 plus 3x. And then these are not like terms, so we have to keep them separate. So we'd have 8 plus 3x over 4x. So that would end up being the final answer to this, and then the restriction is x cannot equal 0. So that is the process for these types of questions. Number 2, first thing you look for, can you factor? Everything is factored, and then notice that we have x and x squared in the denominator, so we know that from those two, x cannot equal 0. That's going to be the restriction for number 2. Lowest common denominator, as I mentioned at the beginning of these, it's not these two multiplied, it's actually x squared, because x can go into x squared and x squared goes into x squared. So we would just multiply this by x and then that by x. So notice we end up with 5x plus 7. Those can simplify, and that's going to be all over x squared. Now at this point, you always want to check if anything can factor in the final expression. So if you could take maybe something out of here, but nothing does factor. So this ends up being the final simplified answer. That's the restriction. Now, if you multiply these together at the beginning, then that lowest common denominator would be x cubed. And we'd have to multiply this by x squared, the top by x squared. We'd have to multiply this by x, the top by x. So we'd end up with 5x squared plus 7x. And then notice we could factor out an x at the top. And then this and that cancel out. And we're left with that same expression, 5x plus 7 over x squared. So that's what I mean where you'd have to do that extra step at the end if you didn't get the proper lowest common denominator at the beginning. But in my opinion, it's best to try to find the lowest common denominator at the beginning so you don't have to worry about that final step. Right? So that's the final answer right there. Number 3, can't factor anything. And then notice that x squared cannot equal 0, which means x cannot equal 0, and then y cannot equal 0. Right? These two expressions in the denominator. And then from here, just get a lowest common denominator. Notice that the lowest common denominator between these two, these are totally different factors. This doesn't go into that, this doesn't go into that, so we got to multiply them. So we'd have x squared y, x squared y. So we have to multiply this by y, top by y, this multiplied by x squared, top by x squared. So then we would end up having 6y plus 2x squared, like that. And then from here, we would have 6y plus 2x squared over x squared y, like that. Notice in the top, we could take out a 2. Right? And notice that the 2, there's nothing going to cancel out with the 2. Maybe if there was like a 4 over here, then we'd have 2 over 4. That would be 1 over 2. But there's nothing like that. So that 2 stays there. So a lot of times when you do factor at the end, nothing will cancel out, but a lot of times it may cancel out. So you always want to make sure you factor everything in the final expression as well. Because stuff may end up canceling out. But in this case it didn't, and this, let me just double check everything, ends up being the final answer right there. Right, so that's the final answer. Those are the restrictions. And then finally, number 4, check if everything factors. Everything is factored at this point. In this case, notice that the restrictions are x cannot equal 0, y cannot equal 0. Right? So now, what is the lowest common denominator between these two expressions? So what's the lowest common denominator between 3 and 4? It's 12. What's the lowest common denominator between x and x squared? Well, it's going to be x squared. And then what's the lowest common denominator between y and y squared? It's y squared. Right, so sometimes you got to look at each of these individually to get this proper lowest common denominator. And so now what you got to do is figure out what do you got to multiply this by to get this. Another way to check is you could take this lowest common denominator and divide it by 3x squared y. Notice that the x squares cancel out. 3 goes into 12 4 times, and then y goes into y squared once. So we end up having 4y. So we got to multiply this by 4y. Got to multiply this by 4y. Then if we apply that same process, we got to multiply this by 3x to get this. Meaning we got to multiply the top by 3x as well. So this would be 8y plus 15x, like that. Yeah. And then we can combine these into one fraction because now we have that common denominator. So this would be 8y plus 15x over 12x squared y squared. Always look, can you take something out from either the numerator or denominator? Can you factor? Can't take out any numbers, can't take out any variables. So this here ends up being the final answer, and then those are the two restrictions.